Hey everybody, welcome back. This is Mr. Schaefer. I have for you today a summary of the three forms that we've discussed on quadratic functions. They are standard form, intercept form, and vertex form. And so here they are, all listed for you together so that you can compare and contrast the different forms. And just to remind you on how to find different key features from each form, I'll take you through kind of the main concepts and central ideas. To begin with, standard form, we learned that the formula to find the x-coordinate of the vertex is opposite of b divided by 2 times a. And that number was the same number of the axis of symmetry. So this vertex x and the axis of symmetry would match. Remember too that the axis of symmetry is an equation. It's the equation of a vertical line, so we should not simply write a number, but x equals a number. The y-intercept always is when x equals 0. And so we can plug in 0, and when we do, we're going to find that the y-intercept is going to have a value of c, whatever the constant is at the end in standard form. So 0, c would be the y-intercept. By the way, the vertex y, this will be the max or min value. That word value is always associated with the y-coordinate. And to find the y-coordinate, you would simply plug in this x number into the function and evaluate the y. So for now, I'll just write down y. Then we learned intercept form. And intercept form, notice, is actually in factored form. The x-intercepts are going to be p and q, p comma 0 and q comma 0. We find those by setting each one of these factors, x minus p and x minus q, equal to 0. Those are also called solutions to the quadratic function. They're also called zeros. Notice also we have that a value, the leading coefficient, in front of the two factors. Sometimes that a value is 1, sometimes that a value is negative, sometimes it's some other constant, positive constant, and that's going to control whether the parabola opens up or down, if it's positive or negative. In fact, we'll add that back here to standard form. Don't forget that whenever you see an a value, it's the a value that controls how the parabola opens. If a is positive, the parabola opens up. If a is negative, the parabola opens down. The axis of symmetry. To find that from intercept form, we actually have to figure out what the halfway distance is between the two x-intercepts. So it's still going to be x equals some number, but I don't really know what that number is. I'd have to count or somehow figure out a way to average the distance between the two x-intercepts. So for now, I'll just write down halfway between the x-intercepts. And x equals a number is going to be the axis of symmetry. Again, it's an equation. The vertex, likewise, don't really know what that's going to be because we're not in vertex form. I don't have a formula like opposite of b over 2 times a to use here. It's intercept form. But whatever number that is, this halfway number would go here in the vertex x, and then find the matching y by plugging in x. Finally, we have vertex form. Vertex form is the form that lets us identify the vertex right away. H, comma, k. Whatever number h is, whatever number k is in that form, we can write those two coordinates directly in the ordered pair for the vertex. One little note here, be careful. H is really going to be the opposite of what you see here. So even though I have a negative h in that expression, it's the opposite of that sign, so positive h becomes the x-coordinate here of the vertex. And remember, the axis of symmetry will always match whatever the x-coordinate is of the vertex. Leading coefficient is a, as we have seen in the previous two. This is a really nice summary of the unit thus far, quadratic functions, which are parabolas when graphed, can be written in 3 different forms, and each form is useful in many, many different ways. We can graph quadratics. Here, number 1, standard form. Find the key pieces of information and then graph the parabola. Number 2, I can see that this is in intercept form. It's factored. Find the key pieces and graph your parabola. Problem 3, this one's vertex form. Find the key features and then graph the parabola. What I'd like to do in closing is to show you a couple extensions on how we can utilize these forms. For example, number 4 says, given the equation, find the key pieces of information. The vertex, axis of symmetry. The first thing I want to do, though, is notice that the form in this problem is vertex form. Once you figure out and establish the form, then finding the key information should become a little bit, or should come more naturally to you. So here the vertex will be 3, 15. 3, 15, H and K. The axis of symmetry is going to match the x coordinate of that vertex. So x equals 3. How will the parabola open? For that, I'm going to go to the a value, so analyze the leading coefficient. What is the sign of the a value? The a value here is -8. A negative means the parabola is going to open down, because a is negative. If the parabola opens down, I'm going to have a maximum. The little vertex way up here is a peak. It's going to be a maximum. The word value means y-coordinate, so I need to find the y-coordinate of the vertex. Well, wait a minute. We just found that back here. 15 is the maximum value. Now, what about standard form? Look at number 5. Here's an equation of a quadratic function. This time it's written in standard form. Vertex. Well, I'm going to use opposite of b over 2 times a. So opposite of 10 divided by 2 times 5 is going to be -1. There's the vertex x, which is also the axis of symmetry. To find the vertex y, I've got to do a little bit more work. We're going to plug in -1 into this function to find out what the output is. 5 times -1 squared plus 10 times -1 and then -1. So 5 minus 10 minus 1, or overall -6. There's the vertex output. How does the parabola open? A is positive, it opens up. And if the parabola opens up, then the vertex is a minimum. The value would be the y-coordinate of the vertex. -6. And then finally, number 6. Here is an equation in intercept form. We had vertex form. I'll write this down, standard form. And finally, here we have intercept form. I know it's intercept form because it's factored. I can see the nice factorization of that function for us. So the x-intercepts would be -9, 0. Got to remember that we're really setting these two factors equal to 0. So x plus 9 equals 0 means that one solution is -9. Set x minus 3 equal to 0. And we find that x equals +3 is another solution. Solutions, x-intercepts, the word zeros, the word roots, they are all referring to the exact same numbers. And that's the numbers -9 and 3. axis of symmetry. It's going to be the halfway point between -9 and 3. If you don't have a picture, one quick way to find that halfway point is to average the two intercepts. So in other words, you take the sum of the two numbers and then divide that sum by 2. -9 plus 3, or -6, divided by 2 is -3. So my halfway point for the axis of symmetry would be x equals -3. Finally, the parabola opens. Check the a value. A value is 4, which is positive, so it's going to open up. There again is a really nice summary of the 3 different forms of quadratic functions and how each one can be helpful and useful in helping you find key pieces of information and key features of a function and a parabola and the graph overall. Thanks for watching.